Oh hey, Jari is hiding behind the trees. Come out to play, Sonny. Ah, hello there. Today's video will be an aggregate of a number of issues we've encountered so far, and how we solved them. A lot of the time when you program something, the stuff you do is invisible. Oftentimes, you'll be spending tons of time doing setup work, while the visual result of your code stays nearly the same. These are things like implementing design patterns, setting up event systems, creating configuration classes, etc. Though it can be boring, setup work is absolutely necessary. I call this process structuring. But when you're finished a round of structuring behind the scenes, you are handsomely rewarded with a session of intense feature adding. And while doing so, you get to look like a computer science god. These are things like adding in more tiles, adding buttons to a GUI, importing new sprites, etc. It's a lot of fun configuring the small stuff once the hard lifting has been done. I call this process swaggering, cause, it's so swag. Be prepared, cause there's gonna be a good deal of structuring in today's video. Okay, so, first things first, let's do some swaggering. In addition to last week's empty and grass tiles, I added in sand tiles into the game, which, upon creation, randomly distribute around 30 to 40 sand pellets within the square. Looking good. We all know that water is essential, so next up is water tiles. Not sure what I was doing with the white fading thingies. Meant for them to be rising bubbles, but they look more like light reflections off the surface. Either way, looks fine. Remember to stay hydrated, people. Next, we added randomly generated terrain. Really quickly, I added some basic Perlin Noise generation, mapping certain elevation ranges to each of the 3 tile types we have. Looks pretty dumb for now, but let's not fuss over it, cause we don't have enough tiles to make anything final. There's some pretty good procedural generation tutorials out there, so I won't go into detail about it here. Check the description links below if you want. The landscape still looks kinda dry, so I added in some vegetation, generated at the highest elevation. We decided that entity data should be attached to their corresponding chunk locations, cause, duh, it's the intuitive thing to do. Wowee! Okay, the landscape is already looking a lot more interesting. Pro tip, add in a little position randomness to make it look more natural. But now we have a problem. Issue number 1. Let's take a look at what happens when we walk behind a tree. Since we are rendering the entities along with each chunk, we don't have any depth rendering. Well, back to structuring. Entity data still needs to stay attached to chunk data because of our deferred chunk loading approach. However, we need to separate the two during rendering. At the moment, every logic update, the logic fetches all of the chunks within render distance and puts it into a list. Then, every frame, the visuals renders each chunk separately. Let's make it so that each logic update, we also extract all the entity data in the chunks and store them in a to-display list. Then, we sort each entity by Y position, so that they get rendered in the correct order, and bam! Jari can hide behind the trees. Moving on to issue number 2. Something was causing our program to stall on startup. Lunkle! Why do I have to wait 10 seconds before the app starts? It was very strange indeed. I had to get to the bottom of this. Thus began the great debugging process of May 2020. Do a print here. Slap a print statement there. Oh wait, what? It works now. Now, if you've been an active part of the online programmer meme community, then you've heard the jokes about sinfully approving an error-prone program without knowing why the error had stopped appearing. But such illegitimate practices are below me. I had to figure out why the heck a print statement would significantly decrease the start time of our program. Thus began the great research process of May 2020. It turned out to be a fruitful endeavor. To understand why a print statement sped up our program, I will have to explain two things. First, the basic structure of our code. We have two major threads, the rendering thread and the logic thread. Both threads run continuously until the universe explodes. The logic thread specifically had a loop that checked every iteration whether a frame time has passed, and if so, updated the game state. Now, the second thing I have to explain is something called a context switch. How most computers create the illusion of parallel threads is through a scheduler repeatedly allocating each thread a small portion of the processor's time. We can view this like the processor is jumping from one thread to another really quickly. The more frequent the jumps, the more fluid the overall program seems to progress. However, context switches are expensive. Each time the processor jumps, it needs to save the context of the current thread, i.e. variables, line number, etc., and then load in the context of a next thread. That's precious processing power being wasted. Hence, the scheduler typically only allows a context switch if 1. The current thread has been running longer than a predefined unit of time, called a time slice, or 2. The current thread needs to wait for like an input, output, or synchronization. It turns out that, all along, the logic thread was hogging the processor's precious time. The print statement I added served as a trigger for more frequent context switching, such that the processor didn't waste time just looping through the logic thread doing nothing. I replaced the print statement with a sleep statement, and mystery solved. Interesting enough, sleeping for 0 milliseconds still tricks the scheduler into triggering context switches, so Programming, a journey of passion and anguish. A true programmer needs to ride the waves of joy and sorrow alike. Your program is a manifestation of both extreme frustration and overwhelming pride. Wow, okay, that was a struggle. See you next week.